just a couple of paintings here for us to look at. And so I just want you to see something. I have these right here. So this one is his self-portrait.
Oh, I've seen this one.
Oh, you have?
Yeah, I've seen that
Okay, so there's that one that he painted, and there's this one that's called Jacqueline. So here's some 3 different ones. So tell me, what do you notice about each one of these paintings? So they have some different things that are like in common.
I would say the biggest thing is there's a lot of geometric shapes.
So we're going to put all these to the side for just a second and look again at just the Picasso paintings right here. Okay, so we're back to these 3. So, out of these 3, which one do you think is your favorite?
I think I like this one.
Okay, I like that one too. That one's a good one. Okay, so let's look at this one for just a minute.
I like it because it's my mom's name.
Jacqueline, really? That's so cool. Do you think you could take this marker and maybe sketch over just a few different shapes that you see inside of the Jacqueline painting right here? And I have a centimeter paper over here that you can use, or I have this ruler. It's totally up to you.
Okay.
That you can use to draw the shapes.
Okay, I see this to here, and then kind of make like a little triangle.
Okay, there you go. Woo! That is a lot of different shapes there, right?
Yeah, very geometric. I can see
my
why it's called
goodness.
cubism.
Yes, for sure. Okay, so it looks like you've done a super good job here. So do you think you can go through and tell me just some of the shapes you used?
Well, I like squares and triangles
Why?
because they just look prettier than those. Like the parallelograms, you have to actually think about stuff and
So it's just easier to work with. I just found out a couple of hours ago that your art teacher here at the middle school, Miss Roberts, wants to paint a modified version of one of Picasso's paintings on her wall. And since we were looking at Jacqueline and kind of working with it, she figured she could go in and just do Jacqueline on the wall because she likes this painting too. But she wants to do a modified version. So she wants it to be in black and white only. So his original painting had a bunch of different colors in it. So she's wanting to kind of switch it up. So she wants Jacqueline, so the shape that you just so the part of the picture that you just drew all those shapes on and stuff, she wants that part to be in white painting. And she wants the rest of the rectangle here to be in black painting. Okay? So anyways, she wants to make the picture or the painting on the wall the same size as the original. But she told me that she is completely horrible at math and she needs our help to figure out some different things.
Okay.
All right, so first of all, do you think that the real painting was the same size as what we have here on this?
Probably not. I mean, I would assume bigger.
I just found out a couple of hours ago that your art teacher here at the middle school, Miss Roberts, wants to paint a modified version of one of Picasso's paintings on her wall. And since we were looking at Jacqueline and kind of working with it, she figured she could go in and just do Jacqueline on the wall because she likes this painting too. But she wants to do a modified version. So she wants it to be in black and white only. So his original painting had a bunch of different colors in it. So she's wanting to kind of switch it up. So she wants Jacqueline, so the shape that you just so the part of the picture that you just drew all those shapes on and stuff, she wants that part to be in white painting. And she wants the rest of the rectangle here to be in black painting. Okay? So anyways, she wants to make the picture or the painting on the wall the same size as the original. But she told me that she is completely horrible at math and she needs our help to figure out some different things.
Okay.
All right, so first of all, do you think that the real painting was the same size as what we have here on this?
Probably not. I mean, I would assume bigger.
Yeah, so when you're in art class and you're painting things, what do you usually paint on?
Well,
do you use just pieces of paper, or do you use canvases or what?
Normally we use 18 by 20 canvas.
Okay, yeah. So anyways, all these canvases are usually a lot bigger than just this little. You never really see canvases that are this size. You really probably have to look for them a lot. So anyways, you're right. So the actual picture is the actual painting is actually a lot bigger than this. The dimensions of it are roughly about 90 centimeters, about 120 centimeters. So what we have here is 18 centimeters by 24 centimeters. So you can tell that that's definitely like a big difference, right? All right, so anyways, that means that the dimensions of the real painting are like roughly about 5 times bigger than what we have here, okay? All right, so anyways, Miss Roberts needs us to figure out how many tubes of 2-ounce black and white paint from Hobby Lobby that she needs to buy in order to paint this on the wall, okay?
Okay.
So again, she knows that she wants the painting to be the exact same size as the original one, so that's 5 times bigger than what we have here.
Okay.
So how do you think we could start out by figuring out how many tubes of like white paint that she needs to paint the Jacqueline part of the painting on the wall?
Well, you can figure out how much using my shapes and stuff is, like there, like the area of that.
Okay, so you're saying we could use the shapes that you drew and find the area of those shapes,
Right.
and then add them all together, maybe? To
Yeah,
find the
yeah,
area.
yeah,
Okay.
yeah.
So how are you gonna go about doing that?
Well, so we already know this is in centimeters, so I guess I could measure it.
Okay, easy to work with. Okay, so why don't you go on and start measuring all this. Okay, so after you've found the measurements of each one of these, all the dimensions and all the shapes and stuff, what are you going to have to do to those measurements before you find the dimensions of the real thing?
Multiply it by 5 times. Well, you multiply it by 5 because it's 5 times.
We're trying to find the area of Jacqueline, and you've already got the scaled measurements here, the scaled areas.
Right. Add them all up.
Add them up. Okay, so let's try that. Here's your calculator right here you can use. Or if you tell me what the area is for the original of Jacqueline.
For the
original painting. So not what we have here, for the original
okay.
big one. What the area is.
4,725 centimeters squared.
All right. So now that we know the area of Jacqueline,
Right.
how can we use that to figure out the area of the rest of the painting? So the part that'll be painted black. What were we working with? What were we trying to find in Jacqueline? The area. So maybe we could say the area of the whole rectangle that's on the actual painting, right?
Yeah.
Okay, so that's easy to do. So earlier we said what the dimensions of the original painting were.
90 by 120.
Yeah. So how would you find the area of that? So if that's the area of the rectangle, and we know the area of this irregular shaped Jacqueline, how can we, let's say, maybe find the difference in the area to see how much remaining area outside of Jacqueline that we have?
Okay. So, well, I have the area of her, so I could just subtract that from the total area.
Okay, yeah, that sounds perfect. So on the back of the black and white tubes of paint that Mr. Roberts is going to buy at Hobby Lobby, it says that one 2-ounce tube will cover about 20 square centimeters opaquely, which means that in order to really cover good, not to have anything showing through, so it's enough to have full coverage. So since it says square centimeters, we know that that's talking about
It's the area.
Okay, so both the paint coverage and Jacqueline's area are in square centimeters, right? Mm-hmm. So how can figuring out the area of Jacqueline, which is what we just did, we just figured out what it was.
Yeah,
so it was
4,725.
Yeah. So how can knowing that help us determine how many 2-ounce tubes of paint that Miss Roberts is going to need to buy?
Well, so if 20 centimeters squared is how much it can cover opaquely, well, you could probably divide the total area of Jacqueline by the 20 to see how many tubes.
It's 236.25, right?
Oh, decimal. We don't like decimals.
Okay. So it looks like you have a weird number, right? Okay. So can she buy, 236.25 tubes of white paint?
No, I don't think they sell it like that.
Yeah, I don't think so either. Okay, so would she need to round down, say, or maybe round up?
Well, my dad always taught me, always round up when you do stuff because you'd rather have more than less.
So we're just going to go and do the same thing for the black area, just the same way that you just done it. And so that leaves room for any extra space that maybe you didn't get in your calculations earlier, since she's kind of like a weird shape and all that stuff. And that's just going to ensure that she has plenty of paint. She's not going to run out or anything like that. The art teacher at the high school, Mr. Connor, wants to paint this painting on his wall too. But he wants it double the size of the original, which would be 10 times the size of this piece of paper that we just worked with here. But I have this paper here that's going to help us guide him on how to go about doing this project and stuff. So do you think you can work through it so we'll have something to give him?
Yeah.
Okay, so these are just a few different shapes that he drew on his Jacqueline painting.
Right.
But he doesn't really know. He doesn't remember how to find the area of these shapes or anything, so you may have to show him how. So here's just some different ones that you can just go by and show him an example of, like a triangle, of a rectangle, and of a square. So